This is Geology 100 Natural Disasters. This is Supervolcanoes and Caldera Eruptions Part 2. At this point, we're going to switch from the Yellowstone caldera to one that is slightly closer to Las Vegas. This is the Long Valley caldera in California. As you can see from this map of ashfall from the two calderas within the western United States, the Long Valley caldera overlaps a lot of that same region. It covers over the Four Corners region, much of the southwest. The most recent Long Valley caldera eruption produced what is known as the Bishop Ash bed. This is an image of the Bishop Ash shown not far from the Long Valley caldera. There are actually two different units of the Bishop Tuff deposited here. There's these lower few meters that consist of the pumice that was ejected and then fell to the ground, and then that upper 5 to 6 meters is the basal part of a pyroclastic flow that swept at high speed throughout the region. We're seeing one big volcanic episode from a single, what we would consider a single eruption, but we can see the different types of eruptive materials that came out at the time. Here is the Long Valley caldera in the large western United States view. Here we are zooming in the Sierra Nevadas, and then it's the basin and range on the interior. What we can see is there is a lake over here, that's Mono Lake, and then this is the Long Valley caldera itself. This whole region, Mono Lake, Inyo Domes, and Long Valley, are all part of the same volcanic system. This stylized map simply shows the Long Valley caldera, and it's called Long Valley because it's a wide but relatively narrow north to south depression. Within there's Mammoth Mountain that is right on the edge of Long Valley itself. There's the town of Mammoth Lakes within the caldera. A few different craters in the Inyo craters. There are the Mono craters, and then Mono Lake itself. It's almost a string of volcanic features that are associated with this either single or maybe a couple of different magma chambers within the Long Valley complex. Now within the Long Valley depression itself, there is this resurgent dome, and it sits almost in the center, and we're going to look at what changes have occurred to that in relatively recent years. Overlooking the region, there are a number of high-standing areas where you can actually get a pretty good view of the topography and the geology. This is a view from effectively one edge looking into this caldera. The history of the Long Valley caldera is complex, just as the Yellowstone caldera is. 3 million years ago, there were widespread eruptions, both basaltic and intermediate lavas, due to the onset of crustal extension. So as the basin and range got pulled apart, new pathways for magma to reach to the surface and form lava flows occurred in a number of locations. 2 million years ago, there were rhyolitic eruptions at Glass Mountain and a couple other points. 760,000 years ago, that's when this big Long Valley caldera event occurred. 600 cubic kilometers of magma, and that is the emplacement of the Bishop Tuff. Between 750 and 650,000 years ago, smaller eruptions occurred, and uplifts started to occur that formed the resurgent dome. Rhyolitic eruptions at 500,000, 300,000, 100,000 years ago occurred on the margin of the resurgent dome. 220 and 50,000 years ago, more basaltic lava filled in the western portion of the caldera, and domes and flows formed a Mammoth Mountain. For the past 40,000 years, the Mono and Inyo craters have been erupting from time to time. Really, the last eruption occurred 550 and 600 years ago in the Mono Lake region. The timing of all these events looks somewhat random. You can see that as eruptions occurred over the past 5,000 years, they were effectively popping off in different spots. Within the Mammoth region, there was lots of hydrothermal activity, these steam explosions. Within the Inyo craters, there were a number of recent eruptions in the past 600 years. But when you look at the Mono craters into Mono Lake, it looks as though the eruptive center moved further north with time. We are seeing what has to be somewhat smaller magma chambers that are causing this action. It's not one single big magma chamber that's producing this activity. There's probably some breaking up that is actually occurring. Now the domes and craters, there are rhyolitic dome eruptions as well as ash deposits. so that a number of these spots are both covered in tephra and have lava that erupted at the surface. This view shows us Mammoth Mountain in the distance, with a couple of other domes in the foreground. There is a stratovolcano-style mountain at Mammoth Mountain, but a number of other domes that erupted from distributed fractures, distributed fissures. Obsidian flows occur within the Mono craters. If you were to drive on 395 south from Mono Lake, you would see a number of these obsidian type flows, very gas poor eruptions, but rhyolitic in composition. So the classic definition of a lava dome. The Long Valley caldera has this resurgent dome right in the middle, and the resurgent dome represents not a volcanic construct, but more importantly, that is the inflating portion of the magma chamber. When we look at the cross section through Long Valley, we can see that there are a number of different layers that are covering over the topography of the caldera itself. So this yellow, these are the post-caldera volcanics and sediments that are accumulating at the top, have covered over a lot of the geologic information. The Bishop Tuff is this thick orange deposit. As this eruption occurred, it dumped out huge amounts of ash into the air, and then ash came back down, the pumice came back down, and it covered over the region, including the vent, the actual eruptive vent itself. There are pre-caldera volcanics that occurred, of those 2 million and 3 million year old events, but for the most part we have a pretty good idea of what's going on at depth because we've been able to drill through these materials and look at the local structure and local topography. There have been a number of events as of late. In 1997 through 1998, there was a swarm of earthquakes and accelerated uplift. Here's a map showing all earthquakes greater than 2.0. You can see that it is occurring all within this resurgent dome, suggesting something was going on that was pushing up the dome, flexing these rocks and causing them to crack and move against each other. That dome continued to inflate from time to time. From the 1996 to 1998, it moved pretty drastically. When this was occurring, the geologists were paying attention to the actual movement, and it suggested that if there's that much inflation going on, centimeters worth of inflation, then there could be magma moving and getting ready to erupt at the surface. So as a function of all this movement that has been occurring over the past few decades, there has been a lot of activity to map how much movement is occurring, how many earthquakes are occurring, the tilt meters and other sensors in order to actually determine what is changing on the surface and potentially the subsurface within the caldera region. In 1989, the swarm of earthquakes included a bunch of deep, long-period volcanic earthquakes and CO2 emissions. The trick behind long-period events is those are directly related to magma pumping through fissures at depth. So long-period or harmonic earthquakes are a pretty good indication that magma is moving. This resurgent dome was stable for a long period of time, but really it is recently that this movement has really started going. So until 1979, it was fairly stable or entirely stable, and since 1979 on, it has drastically shown changes. This unrest includes earthquakes, uplift, and lots of CO2 outgassing in the regions around there. Specifically at Mammoth Mountain, there have been a number of sites where trees are dying because CO2 is coming up through the soil. These tree kill sites, which I have a few images of, are actually relatively dangerous because this is also a skiing destination, and as skiers are cruising down the hill, blasting through the snow, they could easily wind up in one of these depressions that is full of carbon dioxide. Here's what one of those signs look like. Here's what the tree kills look like. They really are a drastic change to the environment in which trees can't survive, and of course humans can't survive either. This magma that is still pretty far at depth is releasing CO2, but that CO2 is making its way up through the fractures and fissures, coming to the surface. Because CO2 is heavier than the rest of the air, nitrogen and oxygen, then it accumulates in low-lying areas. It can accumulate in homes, it accumulates in the soil, it can accumulate in snowbanks, and these become dangerous areas because if you enter it, there is no oxygen to breathe. So what we see in the region is certainly the activity associated with the resurgent dome in the caldera itself, but Mammoth Mountain is fairly active as well. It is the site of lots of carbon dioxide degassing. It's the site of a number of earthquakes, relatively shallow earthquakes, and some deeper earthquakes as you go off to the southwestern portion of the mountain and off the side of the mountain. The best guess for what's going on is that there are actually two different sources of magma. Underneath Mammoth Mountain, it is mostly these deeper intrusions of basalt, meaning more fluid lavas. These are getting pumped full of magma. Those can be causing those deep, long period earthquakes. The CO2 that is degassing is actually rising up through the layers and making its way to just under Mammoth Mountain. So that when we look at this scenario, it looks like it's not that big of a hazard for eruptions. What we're most interested in is what is driving the inflation of this resurgent dome. It could either be that the Long Valley caldera chamber that fed the 760,000 event is dormant, maybe even dead, and all of this uplift is simply the result of these hydrous fluids that were released during that final stage of magma crystallization. So there probably isn't going to be a large-scale eruption. The uplift then is a result from these recent intrusions of a small volume of magma, probably basaltic magma, into the upper 6 to 8 kilometers of the crust. There is a decent amount of evidence for this. The fact that the most recent eruption from the Long Valley caldera magmatic system was 100 or more years before today. The geologic record of eruptive activity suggests that the mantle heat source has moved progressively westward over the past 2 million years towards Mammoth Mountain and further, suggesting that it's moved out of the caldera. The temperature in the bottom 1 kilometer of the 3 kilometer deep hole that was drilled in the center of the uplift is at a stable 100 degrees Celsius. The absence of magmatic volatile emissions around the resurgent dome suggests that there isn't magma that's degassing. There is a lack of mid-crustal long period earthquake activity, indicating that there is no magma moving beneath that surgent dome. However, there is also evidence that the inflation of the resurgent dome is driven by some sort of magmatic intrusion. 75 to 80 centimeters of uplift have accumulated episodically over the past 20 years, 1980 through 1999, and has not subsided. If the inflation was a function of this pressure increase of hydrous or vapor fluids, you would expect this gradual subsidence to occur as it degasses into the surface. It's very similar to what we see at the Yellowstone caldera, that it goes up and it goes back down. The other piece of evidence is that gravity measurements indicate that there really is a mass increase occurring that is right around the density of magma. So the story is based upon these two different sources. First of all, there is the original magma source that is directly located under the caldera itself that could be driving the resurgent dome, but most likely it's fairly deep, and since there haven't been eruptions for quite a while, that could be relatively stable. However, most of this activity is actually based on this western set of events that are occurring beneath Mammoth Mountain and to the southwest. When we look for the most likely location for a future eruption, Mammoth Mountain seems to have way more potential than the caldera itself. But we really don't know what's going on. There could be potential for a big caldera reforming eruption currently under the resurgent dome. So the big question is, what would be the consequences of a Long Valley or Mammoth Mountain eruption? This is where we can start to talk about preparedness and the USGS's response to events that could occur in the Long Valley area. There is a color code system designed to educate the public and state officials and other federal officials about what is going on in the region and what we should be paying attention to. Green indicates that behavior is normal. There have been a number of earthquakes over the past 20, 30 years, occasional swarms of magnitude 3, potentially larger, and the caldera is inflating at a rate of 1 inch per year. The response from the USGS is standard. We are paying attention to what's going on a daily basis and looking for changes. So the condition green means no immediate risk. If there starts to be some intense unrest, such as swarms of magnitude 5 earthquakes or greater, a pronounced increase in the rate of ground deformation, then the condition moves to yellow. And that simply means more intensified monitoring. The USGS will set up a field headquarters in the local region and start informing local agencies about the potential for events. If monitoring suggests we move to the orange condition, all agencies should be prepared for these events should they occur. It's not guaranteeing that an eruption is going to occur, simply the likelihood is much higher than it has been in the past. It only goes to red when an eruption starts to occur. And at that point, it entirely depends on what kind of eruption we're talking about. There could be a small scale basaltic eruption where once it occurs, all you can do is watch it. On the other hand, if there is a large scale caldera forming event, then just as we saw in the video supervolcano, large changes could be coming to the western United States.